Okay, I'll try to keep this video a lot shorter than the Monday one. The big picture of today's work is that you're basically repeating the same kinds of calculations that you did on Monday. You're still calculating ultimately these spring constants for these unknown values on this like sliding scale in the simulation, but you're doing it for second, fourth, sixth, and eighth notch. Yesterday you did that for the third notch. In the video I did that for the first notch. The parts of this table, so the hanging mass, we're still going to use this 250 gram mass. I already put that in the table converted for you because we're going to keep that as a constant in our experiment. So just 0.25 kilograms for everyone. The next column, the weight. So I reviewed how to calculate weight and force of gravity, and we did that a lot earlier in the year. But so if you need to, you can revisit that Monday video for that. I put in parentheses spring force because also in the video I showed that on our free body diagram, our force of gravity or our weight should be equal to the upwards spring force that we have. So you could think about this as calculating the weight. That's also calculating the spring force, though, in newtons. For this displacement, again, we are measuring, so we're not calculating the displacement right now. That's something that we're measuring in this experiment, in this simulation. And you do that by going from this blue unstretched length down to the green resting position line. And I think the biggest thing to keep in mind, one of the most important things to keep in mind, and a pretty common mistake is going to be, instead of reporting this in meters, some people might do this in centimeters. Make sure that you convert whatever centimeters you measure on this ruler into meters. So the example of that I had in the video was on this one notch spring. I have like 62 centimeters about of displacement. So when I write that in this table, I would write 0.62 meters instead of 62 centimeters. So you could basically move the decimal twice to the left, or if you want to see sort of why that works out the way it does, you can go back to the video to see sort of the mathier part of that calculation too. And then the last part is this spring constant. So again, using Hooke's law, knowing your spring force, knowing your displacement, you can solve for that spring constant just like you did on yesterday's work and that I did in the video. The only other notes that I have, this displacement you could technically write as negative. So if you said on this first notch, I would want to write it as negative 0.62 meters. That's totally okay. I'm not terribly worried about the signs that you write here because, again, the signs really depend on the coordinate system you set up. But what is important is that you write your spring constant as a positive number. Spring constants should, I think, always be positive. It's hard for me to think of some example where it would be negative, because if you stretch a spring to the left, it's going to pull you back to the right. That's a restorative force, so make sure that your spring constant is positive. The only other note that I have is for counting these notches. Again, the small setting is like 0, so 1, 2, 3, 4, 5, 6, 7, 8, and then this large setting is like 9. On tomorrow's work, you're going to predict what the spring constant and what the displacement would be for 10th setting, but that's how we're counting these notches here. Okay, good luck, and remember, if you need to, you can revisit your work from yesterday, or if you need to, you can also revisit that video from Monday's work.